Yeah. So we were here, real numbers. Real numbers are just all those numbers which are real, which are taught to us. And it can be decimal numbers or any numbers. So they are just set of rational and irrational numbers. The complete set of rational and irrational number is the set of real numbers and is denoted by R. Thus, Q, which is rational numbers, and QC, the Q's complement set, which is irrational numbers. The union set of both are real numbers. If you're not able to understand it, simply understand it that the complete set, the union set of rational and as well as irrational numbers is real numbers. Real numbers can be represented as points of a line. This line is called a real line or number line. Clear about real numbers?
Yes, sir.
Yes. So all the real numbers follow the order property. If there are two distinct real numbers, A and B, then either A is less than B or A is more than B. When we will study about complex numbers, so their inequality does not exist. So in case of real numbers, inequality is there. So if we represented number line, it has an origin 0 and it is going left to the negative side minus of infinity and right to the plus of infinity because it numbers does not add, they just don't end. Okay, root 2 is a irrational number, pi is also a irrational number, and they are represented on this number line of real numbers. Clear?
Yes, sir.
Yeah. So integers are rational numbers, of course, but converse need not to be true. All the rational numbers must not be integers, but all integers are rational number. That's rational numbers. Let me repeat the numbers which can be represented in P by Q form. So we also discussed it earlier that any integer like 1, 2, 3, 4, 5, 4, let's say 4 has its denominator 1. So it can be represented in P by Q form. That's why they are rational numbers. And it must not be true that every rational number is an integer. Let's take an example 1 by 2. Is it a rational number, yes or not?
Rational number, sir.
1 by 2 is a rational number, right?
Yes, sir.
But it is not an integer because it is 0.5. So it's not an integer. So that's why the converse need not to be true. Now coming to the second point, negative of an irrational number is an irrational number. Okay. Sum of a rational number and irrational number is always an irrational number. So I have an important property for you here. I'm representing rational numbers as R. Should I write? Okay, let me. So this is an important property of rational numbers. I'm representing rational numbers as R and irrational numbers as I. Okay. So whenever we are going to do these operations with rational number and rational number, if there are two rational numbers and if they are getting added or subtracted or multiplied or divided, so the result will also be rational. Okay. And if we are doing these operations with two irrational numbers, all these operations, mathematical operations, algebraic operations, as we call them. So the result can either be rational or irrational. So it's not decided when we talk about two irrational numbers. I'm also going to give you examples. Let me first write another case. If we are doing all these operations, one rational and irrational number, so the result will be going to a rational number. Okay, giving you some examples that any two real numbers. Let's take 4 and 2, and if we do plus minus multiply or divide, so plus will be 6, minus will be 2, multiplication will be 8, division will be 2. So these are all rational numbers, correct?
Yes, sir.
Yeah. And if we take irrational number like uh, this is, if we take one irrational number, this is the irrational number, right? Now the plus will be 4 plus root 2, the minus will be 4 minus root 2, the multiplication will be 4 root 2, the division will be 4 upon root 2, which will make it as root 4 into root 4 divided by root 2. So 2 4 2, it will be 2 root 2, right? So this is also irrational, this is also irrational, this is also irrational. So this is the example of our second property. Clear?
Yes, sir.
Yeah, let's take the example of this property where we take two irrational numbers. Let's take square root and square root 2 and 2. So if we are going to do all these operations, on doing plus, it will be 2 root 2. On doing minus, it will be 0. On doing multiplication, root 2 into root 2, square root 4, which will be 2. On doing division, it will be 1. Sometimes it is irrational, sometimes it's rational. So it's not clear. So it can either be rational or irrational. Is this point clear?
Yes, sir.
So these are three properties which you must take a note of. Other than this area is the examples only. So take a snapshot.
1 minute, sir. Yes, sir.
Yeah, done.
Yeah.
Done everyone. Rishi.
Still he didn't connect to the audio thing, sir.
Ah. Okay. Stubborn text. So yeah. The product of a non-zero rational number and an irrational number will always be an irrational number. The product of a non-zero rational number. Okay. An irrational number will always be an irrational number. So there's also one exception to our rule where we were saying that all irrational numbers, whenever they get operations like these, so it will be the result will be an irrational number, except in the fact when we are multiplying zero as a rational number to any other irrational number. So the result will be zero, which is a rational number. So this is an exception. So write this exception in your notes. The fourth one. Now the next point is if A belongs to rational numbers and B is an irrational number, then AB is a rational number only if A is zero. So says the same thing. Some difference product and quotient of two irrational numbers need not be an irrational number. Okay, we also discussed about it. Some difference of two irrational numbers need not to be an irrational number. So we also discussed about it in the property. Clear about rational and irrational numbers and real numbers?
Yes, sir.
Okay. So now before proceeding, we are just going to we are just going to look at the concept of complex numbers, and in detail we will discuss it later. Complex numbers. So this whole complexity started with this equation when we were discussing about this equation. Solution of this will be, now after taking root, so earlier than this we were not able to find square root of any negative number. Square root of negative number was not in our syllabus earlier than class. In class 10th in lower classes, we were not discussing about any square root of a negative number. But now we have to face this concept. And this square root of -1 is called as iota. This is termed as iota, and the whole new axis is made upon this. So earlier we were having a number line like this, minus infinity to plus infinity. Let's call it as plus real to minus real. And now we have to also take one more axis because on 0. Now we have to take one more axis where we are going to discuss about the imaginary number, positive imaginary and negative imaginary. And the unit will be iota. Like the unit of like 1 kilogram is the unit of like while purchasing bananas, and it depends on reasons whether the bananas are available in dozens or not. But like here in Kotputli in Rajasthan, they are available in kilos. So the unit is 1 kilo. So in the same concept, the kilogram is the unit of kilogram is the SI unit of weight, right? So that's how when we talk about imaginary numbers, the unit, the smallest unit, just like cell is the smallest unit of a body. In the same way, iota is the smallest unit of imaginary axis. Okay, then complex number are formed based on there will be some, like if there are two axes, so there can be points lying here also on axis, here also on axis. So whenever the point is lying in between these two axes, this will be known as complex number. Actually, complex number is every number wherever it is lying, it will be known as a complex number. But if the number is lying on the axis, then we may call it as complex number and as well as purely real number. And if the number is lying on this axis, then we may call it, of course, it is a complex number, but we can also call it as purely imaginary number because it do not have any significance for the reality of that number. Yeah, so it's not real number. So it's purely imaginary. And if the number is present on the number line, then it is purely real. Which numbers are on the number line? Like 1, 2, 3, 4, and also the points in between them. Like real number, the real numbers are what? All rational and irrational numbers represented by Q and Q's compartment, right? So all these numbers are present on this. So they are all purely real numbers, and as well as they are also complex numbers, but they're missing the part of having imaginary. So complex number are represented by this real number part plus imaginary number part. Real number represented by X into iota being the unit and Y being the imaginary part here. Iota being the unit of imaginary part and x is the real part of the number. So it's just to make you an understanding of what complex number are. We are going to discuss this in more detail when we will learn this chapter. This is a unique chapter for this, and there's a different distinguished chapter. Okay, whatever I told you, is that clear?
Yes, sir.
Yeah. So complex number, a number of the form a plus iota b. A is real part, b is imaginary part, iota is the unit of imaginary, and the unit of real numbers are simply 1. That's why it's not written here. It's called a complex number. Complex numbers, now we have to understand it in this scenario that natural number are contained in whole numbers, because whole numbers also include natural number and as well as 0. So natural number, let me draw a Venn diagram for you, that if it is a natural number, so natural number are there and whole number are, like in whole numbers there are natural numbers, and when we talk about I means integers. When you talk about integers, so in integers there are whole numbers as well, and in whole numbers there are natural numbers as well. And integers are included in all the rational numbers. Okay, they are all rational numbers. And all rational numbers and as well as irrational numbers, these are all real numbers. And all real numbers come under complex number, because complex number have both, like it's just the ultimate universal set of numbers, complex numbers. Okay, as far as our understanding goes. So this is how Venn diagram of it looks like. It's similar to, let me explain you in some different manner. First, what is a Venn diagram? Venn diagram. Just a minute. Yeah, so just now my parents are drinking tea. Okay. So if tea is a universal set, what is there in the tea? There is milk.
Milk,
And what else?
sugar,
Load of sugar in case of my parents.
tea powder, and sometimes water too.
Yes, of course. Water. And other materials are there, right?
Yeah,
So let's take something else. As a school, there are classes. And in classes, what is there? Students.
students.
So in students, what are their brains? Anyways,
Well,
so in this Venn diagram, like school is having classes as well, and classes are having students. But students are not having school. Students are not having classes in them, and students are not having school. So it's like a small part of school is consist of students also. There are classes also. There are teachers also. There are other things also. So it's like a Venn diagram in which we understand what part is in what. Okay. Like there's a building is a big set, and there are rooms in it, and rooms there are drawers in it, something like that. Okay, so it's the same analogy. It's the same here also, that natural number and then whole number, then integers, then real number, then rational numbers, then real number, then complex number are the biggest set. The complex number is the biggest set of numbers. Understood?
yes, sir.
Yeah. So now let's discuss about divisibility test. Oh, sorry. I was speaking with mic off. Is the PDF visible?
Yes, sir.
Yeah. So we are going to look. Let's take a random number. Mm, okay, let's take 3,62,880 as a number. And let's first talk about the divisibility rule. We are discussing about divisibility rule. 2. Now, I'm not going to tell about the divisibility rule of 2. Anyone who can tell?
Divisibility rule.
Yes. So, like, if there is a big number in front of me, how will I, like, rules help us to understand and to decide after watching a number that whether this number is divisible by certain numbers or not, like 2, 3, 4, 5, 6, 8. So, how will we decide whether the number is divisible by 2 or not? What is the rule for divisibility?
I actually forgot about that, sir.
Simple, even numbers. All even numbers are divisible by 2, and all even numbers and with the unit digit of all even numbers are 0, 2, 4, 6 or 8. Okay?
Yes, sir.
Yeah, no problem. Oh. About 3. So in this case, whatever the number here, if we are discussing about this number, so is this number an even number?
Which one, sir?
This number 3,62,880.
Yeah, sir.
So will it be divided by 2 completely?
Yeah, sir.
Hmm. So the divisibility of 3 says that if the sum of all digits of the given number is divisible by 3, then the whole number will also be divisible by 3. Okay, let me repeat. If like there is a given number, if the sum is divisible by 3, then uh, this percentage sign represents that we are dividing sum by 3 and the remainder is coming out as 0. Okay. Percentage sign says that we are writing the remainder, not the denominator. Sorry, not the quotient. Okay. Dividend. Sorry, divisor, dividend, and here we write quotient and here we write remainder. Right? Right?
Yes, sir.
Yeah. So whenever we have to write remainder instead of quotient, then we use this sign. So if we are dividing any sum of digits of given number, and if that is divisible by 3, then the whole number means the complete number will also be divisible by 3. Okay, so let's discuss about this number. 3 plus 6 plus 2 plus 8 plus 8 plus 0. What is this? What is the sum? What is the sum? 27. Is
27.
27 divisible by 3?
Yeah, sir.
Yeah, so its remainder is 0, right? So this number is going to get divided by 3 completely. Do you want to try? 1, 3, 2, 6, 6, 0, 2, 0, 8, 9, 1, 8, 6, 18, 0, and there is a 0 remaining. So this is the number which we will get after dividing this number by 3. Okay, so yes, this rule is working. The rule is that whatever the number is given to us, we'll have to sum the digits. That's how we have done it. And if the sum is getting divided by 3 completely, then our whole number will also be divisible by 3. Correct? Understood? Understood, everyone?
Yes, sir.
Yeah. Please ask if there is any doubt.
Yes, sir.
Let's discuss about 4. Okay. Let me first tell you what is like if we write any number in case 3628880. So this is our unit digit. This is our 10th digit. 10th digit. This is our hundredth digit. This is our thousandth digit. This is our 10,000th digit. This is our lakhs digit. Okay. So when I say last two digits, so we have to look from the right most digit. So this is our first last digit. Second, last two digits are 80. Last three digits are 880. Last four digits are 2880. Clear? Any doubts?
No, sir.
So now the divisibility rule of 4 says, as we are discussing about the divisibility rule of 4, sorry, 2. So it's the same, 2 raised to power 2, it's 4. So the last two digits of the given number, if they are divisible by 4, then whole number will be divisible by 4. If the last two digits are divisible by 4, then the whole number is also divisible by 4. And the whole number will also be divisible by 4. And its remainder will be 0. There will be some quotient. Clear? Should I repeat?
No, sir.
Yeah. So if the last two digits, 2 raised to power 2, if the last two digits are divisible by 4, then the whole number will also be divisible by 4. Okay, so let's now discuss about, so and it will go on also. Let me just tell you, if we will be discussing about 2 raised to power 3, which is 8. So last three digits, if last three digits, if they are divisible by 8, then the whole number will also be divisible by 8. Last four digits, if they are divisible by 16, then the whole number will also be divisible by 16. So it's a logic. It's a note that you can write. I will also click the note of my notes and will send it in the WhatsApp group. So you may not be worried about the what should I say, unmaintained, or about my handwriting while writing these notes. Just have to understand it here. I'll send the notes separately. Okay.
Okay, sir.
Yeah, so it will go on like this, and 2 raised to power 5. Last five digits, last five digits, 3, 4. Last five digits must be divisible by 32. Then the whole number will also be divisible by that. And if also the last five digits are 0, 0, 0, 0, then also we'll consider that the number is will get completely divided by 2 raised to power 5. And same goes for this also. If the last digit is 0, the last digit here is 00, the last digit here is 000, then we consider that the number is divisible by 8. Okay. Understood the logic?
Yes, sir.
Yeah. It is also the same with 9 raised to power 2. For 9, which is 3 raised to power 2, it says that if the sum of all digits is divisible by 9, it is divisible by 9, then whole number will also be divisible by 9. Okay. And if any number is divisible by 9, then the number which is the number from which it is getting divided, the remainder will be then 0 in that case. So here we will write when x is getting divided by y, the remainder is coming out as 0. So that's why we are saying that x is divisible by y. So that's how I'm writing these conditions. Okay. So this is about 3 and 9, the divisibility of, we have discussed about divisibility rule of 2, 4, 8, 16, 32, and it goes on, and 3 and 9. Okay, let's check about 9. 3 plus, when we have summed the digits, what was the sum? What was the result? What is the sum? 27 was it?
7, sir.
Yeah. So when 27 is divided by 9, so it is getting completely divided, right?
Yes, sir.
Yeah. So it will also be divided by 9. So what we have checked about 2 done, 3 done, 4 done, and 8 done. How 8? If we divide 880 by 8, then it will also get divided completely by 880, 110, right? So 8 done and 9 done. Now what is remaining? 5. Everything clear till now?
Yes, sir.
362880. 2 done, 9 done, 8 done, 4 done, 3 done. So about the divisibility of rule of 5 says if the unit digit, if the last digit of the number is 0 or 5, then number is then the number will be completely divisible by 5. Okay. So in this case, will this number be completely divisible by 5 or not? The unit digit should be 0 or 5. If they are unit digit of any number, the last digit of any number is 0 or 5, then the number will be completely divisible by 5. So is this number divisible by 5 or not? Yes, please respond.
Yes, sir.
Yeah, why?
It ends with 0.
Yeah, so the number is also divisible by 5. The number is symmetric. Let's discuss about 6. So the number 6, divisibility rule says that the number must be divisible by given number must be divisible by 2 and 3 also. So if the given number is divisible by 2 and 3 both, then the number is divisible by 6 also. And how we will check about the divisibility of 2? Please unmute yourself and speak. How we will check whether the given number is divisible by 2 or not?
Whether it's even number means the last.
Yes. So about 2, the number should be even, and about 3.
We should add that, and if
Hmm.
it's like, for example, it's giving 27 and 27 comes in the 3, it's a multiple of 3, and so it will be divisible.
Right, right. So where we will sum all the digits of the given number, and digits are basically like digits are all these numbers. These are called digit, and the whole number is as an entity is known as number. So we'll sum all the digits, and if the sum of the digits is divisible by 3, then the whole number will also be divisible by 3. So this is about the divisibility of rule of 6. So was the number divisible by 2? Is the number divisible by 2? Is the given number
Yes, sir.
is the given number divisible by 3?
Yes, sir.
So it is also divisible by 6. Okay. Now let's discuss about the divisibility rule of 7, which is very special. It says that the last two digits, when we will subtract the last two digits from the number, then the number, like, let me write, if there's a number like this. If we subtract the last two digits from it, and if the number in the subtraction result is coming out as a divisible of 7, then the whole number will also be divided by 7 completely. Let me give you an example of this number itself. That 36880. So 36880. Sorry, 362880. So let's subtract the last two digits from the number. Now, what will be the result? Be something like that. And if still the number is big, so you can further on check for it. I have done a mistake. The number should get double before subtracting. So we have to multiply the last two digits by 2. Okay. So in this case, 3628 minus, when we will multiply the last two digits by 2. So we are going to subtract 8 zeros to 80 into 2 is what? 160. So subtracting 160 from it, 8 and 12 minus 16, sorry, 12 minus 6, 6 and 35 minus 1, 34. So now, no, I have done another mistake. Wow. We have to double only the last digit. If this is the given number, so what we will do, we will double the last digit only, like the last digit only. And if the subtraction is getting completely divided by 7, then the whole number will be divisible by 7. So taking its example, 36288 minus 0 into 2. So basically it will come out as 36288. And still the number is big, you can do one more operation, similar operation on this. How? 36828 minus the double of last digit, which is 8. So 2 8s are 16. So the answer will be 8 minus 6, 2. 2 minus 1, this 3 6 1 2. Now if still the number is big, you can further do subtraction of the double of the last digit. The answer will be 357. So 357. Now let's check whether it is divisible by 7 or not. 7 5 is 35. 7 1 is 7. So it is divisible by 7. So the whole number will also be divisible by 7. Understood, or should I repeat once?
So could you repeat once?
Yeah, sure. So clear first. Yeah, divisibility rule of 7 says that when uh, we have to we have to we have to multiply the last digit of the number by 2. Yani we have to double the last digit of the given number, and then we have to subtract the double part. Like if the given number is this, and the given number is having digits like A, B, C, D, E. So we have to double the last digit, which is E, and we will subtract it from the remaining. And if the subtraction is divisible by 7, then the given number is divisible by 7. Let us take an example of 357 as a number. So if we will double the last digit to 7 to the 14 and remaining will be subtracted from it. So what is this? 5 minus 4 1 and 3 minus 1 2. So if and we know 21 is a multiple of 7, so it is getting divided completely by 7. So it now this complete number will also be divisible by 7. This is the rule. Understood?
Yes, sir.
Completely. And if you're checking for some big number, so still after doing once, after like subtracting the unit digit, and after doubling the unit digit and subtracting whatever the result is coming, we can repeat the operation to make the number further smaller. Okay,
Yeah, sir.
let me give Sol an example. So 36288, the unit digit will get doubled and subtracted. So the number will remain the same. Now still the number is big. So we can repeat the operation. 36288 minus 8 into 2, 16, which will come out as 213612, right? Yes, yes. So if still the number you feel if the number is big, we can repeat the operation, which is 357. Now 357 is divisible by 7. How? 751. So yes, it is completely divisible by 7. So the given number is also divisible by 7. Understood?
Yes, sir.
Completely? Any doubt?
No, sir.
Yeah. So the given number is also divisible by 7, 2, 3, 5, 6, 7, 8, 9. So the random number was not random. It is a magic number which is divisible by everything. Even if we divide it by 10. So for the divisibility rule of 10 says that the last digit must be 0. The unit digit must be 0. Okay. And 400, the last two digits must end with double zero. And for 1000, the last three digits should be triple zero. Okay.
Yeah, sir.
Yeah. So why this number is getting divided by all of this, we will understand it when we'll understand about factors. Okay, basically it is nothing but it's 9 factorial. 9 factorial of anything is what? Tell me what
90.
is 3 factorial?
3 into 2 into 1, which is 6.
Yes, good. Similarly, 9 factorial is written in this method. So whatever the 9 factorial will be, it will be a factor of 2, right? Understood? Whatever the 9 factorial will be, it will be divisible by 2
Yeah,
because
sir.
it's having its factor. So it will be divisible by 3, 4, 5, 6, 7, 8, 9 as well. Notice 9 factorial. Booyah, it is the same number which we were discussing about. Okay. So
Yes, sir.
that's why the number was divisible by everything. And if it is divisible, and if it is having factors 5 and 2, so the unit place will be like it is getting multiplied by 10. So it's damn sure that the unit place will be 0. So it will be also a factor of 10. Correct?
Yes, sir.
So that was the reason. So we have discussed about divisibility test, and there are some examples. Consider these examples in the tomorrow's class. We'll also look at LCM and HCF, and we'll also discuss the remainder theorem and also the identities which are very, very important. Okay. So shall we conclude our class now?
Yeah, sir.
Okay. Thank you. Once again, happy Children's Day.
Thank you, sir. And for you too.
Okay. Jai Hind.
Jai Hind, sir.